Hello, I'm Mr. Martin, and today we're kicking off our series talking about building theatrical units such as flats and platforms. And for this particular video session, the kickoff, we're going to start talking about dimensional lumber. In other words, the very basic building blocks of what we use for building our flats and platforms. So, in high school theater, that means wood, okay? If we move up to the collegiate or professional level, that's being supplanted in part by stuff such as welding up metal flats and so forth. But the skill level and so forth required for that is going to be a little high. The nice thing about wood is that we can teach you everything you need to know in terms of operating it and using it safely, all the tools and everything, without requiring an entire semester just to get to that point. So let's begin with our lumber itself. So what we have are our two basic pieces of lumber that we're going to use most often, and that's going to be the 1x4 and the 2x4. That refers to what we call nominal dimensions, and we'll get into the difference between nominal and actual when we talk about sizing here in a moment. But we use wood for a variety of reasons. It has the advantages of being relatively lightweight, and that, as I said, that's a relative term, and relatively strong. Again, that's a relative term, but we do need to know how to apply proper construction techniques so it remains strong. So what we do is we look at the biology of wood, and you're going, but this is theater. Why do I need to know about biology in theater? Well, the biology of wood is going to have a lot of impact in how we use it and when it is safe or not. And please always remember, our overarching concern when we build sets is safety. Safety for you as the builder, and safety for our actors and crew that are on stage. And if we don't build it right, and we don't build it strong, that is a safety issue. So let's look at some of the things that will impact our ability to use it. Now we all know lumber comes from trees. Trees come from plants. You learned that probably even before you were in school. Why does that matter to us? Well, because what we're dealing with is essentially a collection of dead plant cells. And that's going to impact the way we use it, the directions that we can put it together, and some of those characteristics that we're going to have to keep in mind. So, as we look at it, you'll note, most of you know that these are knots where the branches grew. We know that lumber is going to have three basic surfaces, or if it's square, it will have two. We're going to have the face, the wide side. So both of these have a face. Both of these have two edges and two ends. And some of the characteristics are pretty different. Now there's not a lot of difference between the face and the edge except dimensionally. We're always going to refer to the face as the wide side. So, you know why you can't trust it's 2x4? It's two-faced. Yeah, I know, it's really, really funny, right? No? Okay. Yeah, well, standard teacher humor. We then have the edge, okay, which is just going to be the skinnier part on both of these. And then we have the end. Now, the end is significantly different from the other two surfaces because what we call the end, no matter how it's cut, is going to be where the grain is exposed, like so. And so remember we said it's a dead plant. And those plant cells are really, really super long and super small around. But once we have cut this down, once we have dried it out, that becomes like a collection of little straws all bound together. The end grain is going to soak up any liquids, whether that's glue, paint, whatever we're applying to it. And so it doesn't paint well, it doesn't glue well, So if we're going to glue or paint, we tend to prefer to paint the face or edge. And usually we have to do both. Now we have to paint the end sometimes, but you'll discover that it often takes multiple coats. And it just doesn't glue up very well either. The other thing is the strength, okay? Because this is like all those straws bound together with the straw running this direction, wood tends to split very easily, what we call with the grain, okay? So if I take a nail or screw or splitting wedge, it will split very easily this way, but it doesn't split easily this way, okay? So that makes a huge difference in how we're going to place it. And we'll talk about that when we're actually putting together our flats and platforms, but we need to know that, okay? The other thing is, it's very, very rare to have a perfectly straight piece of lumber, especially if you get very long. If you have a board that's 8 feet long, it's probably not totally straight. And that is because, again, it's dead plant cells. And especially, like this is much more likely to be straight than this, okay? And the reason is this has a lot of knots, okay? As we said, that's where the branch tried to grow out. But you'll note, you can see the grain. The grain is prettier this direction. It's more interesting because it wraps around, it makes all these patterns, but it's also weak here. So wherever there's a knot, it tends to weaken the lumber. It also makes it tend to bow. So you get a little bit of moisture back to the wood. In other words, it's soaking up moisture, humidity, even through that end grain. It will tend to bow, and it does so usually around the knots. So we'll get twists, knots, so forth, and sometimes chips. The other thing is that while this is weak, it tends to be brittle, so if you hit it with a nail or screw, it may break the wood or it may bend the nail. So I've often had students nailing into the lumber and then realize that the nail is coming out the side of the lumber. And generally the reason is not that they can't nail, but that it's hit a knot and it's actually bent the nail. So that can be just how strong it is. Now, let's move on and talk about the sizing of lumber. It has been standardized. Wherever you go, if you buy lumber, you'll go in and you'll refer to it when you say, I want a 2x4 or a 1x4 or a 1x6, whatever, and it should measure the same. Whether you're in Maine, Texas, Missouri, California, wherever you're buying lumber, it should be the same. Whatever company put it out, and that's because they went through a long and kind of ugly fight over standardizing this. Now the sad thing is, when we said this is a 2x4, we would think that it would be 4 inches wide and 2 inches thick, and a 1x4 would be an inch thick and 4 inches wide. But we're going to discover that's really not the case. Those are what we call the nominal dimensions. So when you go in and ask for that size, they know what you're talking about, but unfortunately that's not the actual dimension. So when we say something is a by 4, we're going to discover that it's actually going to be 3.5 inches. So if it's a 2x4, it's 3.5 inches wide. If it's a 1x4, it's 3.5 inches wide. If it's a 4x4, it's 3.5 inches by 3.5 inches. The thickness can also be confusing. The 2x4 is actually going to be 1.5 inches. And so whether it is a 2x4, 2x2, 2x6, 2x12, whatever, if it's 2x, that means 1.5 inches thick. Whereas a 1x4 is going to be actually 3/4 of an inch, so half as much, if that makes it easy. So 3/4 of an inch thick. So again, whether it's a 1x2, 1x4, now You'll also note that when I say these dimensions, I'm almost always giving an even dimension, okay, in terms of the width. So if you go to buy lumber, you can't, for instance, go and say, I want a 2x7. They don't really make those. The one exception to that, and it's really even hard to find today, would be a 1x3. You occasionally can find those, but typically your width measurements are going to be even dimensions. Then they mess with you by having these actual dimensions not being what your nominal are till you go to order length. Then it's going to be the actual. I have a question.
Why do they call it a 2x4 if it's not a 2x4?
Well, what we did is we started off, and you can still buy what we call full-size lumber. Although full-size lumber is going to look different, you know. I could take off my gloves, I can run my hand, and my likelihood of getting a splinter is very small on this. Whereas full-size lumber, you'll still see the saw marks, it'll be very splintery. What they've done is they've planed this down. They've smoothed it down. And also because the full-size was kind of hard to work with because of that. And so it used to be for a while, way back in the early 1900s, that you went in and if you bought pre-planed lumber, it might vary. And then organizations came up with that standardization. But they still charge you for what was originally cut. And then they take and plane that down and they make it into other products that we'll talk about later with lumber byproducts. Yes, another question.
Have you ever done martial arts where you break a board?
I have not, but that brings us to an interesting point. Here we have a 1x. You'll note when they break lumber, they're almost always using 1x because it's thinner. And this is a 1x8, which in this case is actually 7 1/4 inches. So the wider it is, the less you can count on as standard. But what they usually do is when they break it, you'll note they have it turned so that they break it with the grain. Okay? And if you were to turn their board, they might not be able to break it because the lumber is so much stronger. This particular board is probably really weak right here. And so if I were wanting to break boards, I would cut this smaller and then I'd hit it right there because that's probably not a very strong point. So, yeah, it's, so let's look at some of our dimensions. As I said, we've got the 1x2, so it is again 3/4 of an inch, but you'll note this is 1 1/2 inches. You can buy this. This is going to be really weak right here. See how the knot takes in almost the whole width of the lumber? So, and then we can go wider and wider. So, today we've talked about some of the characteristics of lumber, how that's going to play into what we do, and the sizing of lumber that's going to matter to us, especially the actual versus nominal dimensions of lumber. So our next video is going to be covering lumber byproducts, or what we more commonly call sheet goods. So, thank you very much.